God bless you, geometry students. This is a review, fairly short exam review, thinking of helping you to be able to be well prepared for this upcoming exam. Some of you have it on Monday, tomorrow, some Tuesday, some will have it on Wednesday, and some will have it on Friday. So I trust by God's grace you'll be able to derive some kind of benefit from this. So Father, I ask your help, I ask your leadership, I ask your diligence, helping us to be well prepared for this upcoming week, and for your blessings and protection and peace and powerful covering over the Christmas holiday season for everyone. Amen. Here are a couple of questions from this past test or practice test. I'm going to do this one with you. It says the endpoint of CD, there should be segment CD, RC at 8, 1, and D at -4, -4. Find the midpoint. The midpoint formula is what we'd employ here. So you write the midpoint formula, x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. It's a good idea to identify your ones, although some of you, I'm sure, could do it mentally. But let's say these are the ones, and these are the twos. So this will be x2, comma, y2. And we'll work it out as follows. x1 plus x2 would be 8 plus a -4. Divided by 2. And the y coordinate would be 1 plus a -1, or just 1 minus 1, divided by 2. So 8 plus -4, or 8 minus 4, would be 4, divided by 2. And the y coordinate would be 1 plus -1, or 1 minus 1, which would be 0, 0 over 2. So the coordinates of the midpoint would be 4 divided by 2, or 2, comma, 0 divided by anything is 0. So that would be our answer there. How about this one, number 6? Segment JK has a length of 2 units. If segment LM has endpoints at 3, 1, and M at -1, 4, how much longer is segment LM than segment JK? So let's go ahead and find the length of segment LM. The length or distance from point L to point M. For that we will use the distance formula. I'm sure you know this well. So this would be x2 minus x1 all squared plus y2 minus y1 all squared. Here we identify our twos. Let's say these are the twos, x2 comma y2 there, and the ones here, x1 comma y1. And we use the formula now. In terms of numbers, x2 minus x1 would be -1 minus 3. That is squared, plus y2 minus y1 would be 4 minus 1. That's all squared. Let's take it over here. -1 minus 3, what would that be? We have two negatives. Remember I've told you this. You get a bigger negative, so that would be a -4. That's squared. plus 4 minus 1 would be 3. That is squared. Negative 4 squared would be negative 4 times negative 4, so that would be a positive 16. Can be positive about that. And then 3 squared would be 9. So 16 plus 9 would give us a square root of 25, and that would be 5. So the question here is, this segment has a length of 3. LM, how much longer is LM than JK? So if this has this length of 2, it should be 5. Take away 2, that would be 3, and the answer is not there. But it should be 3 units longer. Okay? So that would take care of that one. 3 units longer for that one. Let's go to another one which would be applicable to what you have to do. For example, this one here, name the right angles in the given figure, the right angles. One of them would obviously be this, angle FAE. So angle FAE would be a right angle. There are others. This one here with the box, angle BAC, would also be a right or righteous angle. And then this one right here, since this whole thing is 180, and this is 90, then this one would have to be 90 as well, right here. Because this 90 plus 90 is 180, so angle EAC would also be a right angle, as well as this one over here. This whole thing is 180. Since this is 90, and this would have to be 90 also. So angle FAB. FAB, sorry, B. Alright, so what we have is that we have this segment is perpendicular to this one. So we have 4 right angles formed here. Alright, so let's go to the other page. Okay. This one would be a distance formula. Again, find the length of the diagonal from A to C. Diagonal AC. Yeah, so distance formula, we already did one like that. So let's see if we can pick up some other types that would be useful to you for the exam. Okay, what do we have here? All right, how about this one? For the diagram showing find x. Well, what we have is we got a line here. We have an angle here, which is 11x. We have another angle here, which is 4x minus 15. Now, these two angles added together, I'm sure you know what those are. They add together to give you 180. So you'd write for the setup 11x plus 4x plus 15, 4x minus 15 rather, equals 180. Okay, and this is a very, very classic setup with algebra. You do the like terms first. So you do the x's together, 11x plus 4x, that would be 15x minus 15 equals 180. And now you can think about adding or subtracting the same thing to or from each side. So here, let's do the 15 added over here, 15 added here, 15 is gone from the left side, so we have 15x only surviving on the left equals 5 plus 0 is 5, 8 plus 1 is 9, and 1. So my last step, I'm sure you know what that is. We're going to divide both sides by 15. So we have x 195 divided by 15. We can take it down here. 195 in the box. 15 here. 15 can go into 19 once. 1 times 15 is 15. We subtract 9, take away 5 is 4. Bring down to 5. 15 goes into 45 3 times. So the answer here is x equals 13. So that's what you do with this kind of question if you see a linear pair of angles. Okay? Let's go to the other page. Okay, what do we have here? Let's take, well, the most important first. Write a verse which highlights the importance of central features such as midpoints and bisectors. I trust you remember this one, central features. Hear the word central, and that talks about the heart. So this would be what the Lord said to Samuel. Don't look at his appearance or at his outward, his physical stature, because I've refused him. But the Lord does not see as man sees, for man sees the outward appearance, but the Lord looks at the heart. Let's see what else we've got here. Using your compass and ruler, construct a perpendicular bisector. Use point O as a point of intersection, and let segment SP be the perpendicular bisector. We did this one in class, so I trust you'll be okay with this. What you do is, and I don't have the instrument to show you here, but you use one endpoint as your center. You open up your instrument to more than half of the length of the segment, and you make an arc. Something like that. Then you keep the same setting. Use the other endpoint as your center. Make a second arc to intersect the first arc in 2 places. Of course, it's going to look much nicer than this because I'm doing it by hand. And you take your ruler and you line it up so that you can draw a segment between these 2 intersections, and you go like this. And this, with the supposed midpoint at O, and your segments SP, segment SP should be your perpendicular bisector, and if you measure the distance from O to D, it should be the same as from O to G. In addition, if you measure this angle here, angle SOD, it should be 90 degrees. Okay? So that will give you the construction of the perpendicular bisector. What else do we have here? Let's go to another practice test or test that we had. Let's see what we have. Let's look at the very last one. I think I can. This is the one. Okay. A postulate. This one you should know. A postulate is I'm sure all of you can just rattle that off. A statement accepted as true